quizzes go, by the way. Everything I thought was graded in input, but I had several kids say that they did retakes and that they weren't in, which I have to go back and look. Sometimes I don't always write in there when retakes don't go up, so I'm thinking maybe they just didn't go up on the retakes. But I'm going to go back and look at it and see if I have a stack maybe that I didn't actually input. Don't count on it. I didn't have any retakes left in my backpack, but it's possible one of those stacks maybe wasn't input. Oh, watch these. Actually. Okay, so again, for the recording, very quickly, we're doing right triangles right now. We said the two angles that are not the right angles have to add up to 90. So because we know that there is a 90-degree angle, and we know all triangles add up to 180, that means the other two angles have to add up to 90, because we basically be subtracting out the 90 degrees from the 180, which means we have 90 degrees left for the other two angles. Now we've moved on to the sides. We said there is a specific relationship between the sides of a right triangle, and that is the Pythagorean theorem. A squared plus b squared equals c squared. And now we're pretty much caught. All right, so again, the Pythagorean theorem has absolutely nothing to do with angles. Don't try to do anything with that with angles. Just like the fact that the three angles add up to 180 degrees, that 180 number has nothing to do with the sides. That's two of the biggest mistakes kids make. And maybe not biggest. Two mistakes that should never be made that get made. 180 has nothing to do with sides. Pythagorean theorem has nothing to do with angles. This is only about the length of the sides. The length of the sides. Only. A and B don't really matter. A and B are called the legs. And I will sometimes, often refer to them as legs. The book will almost always refer to them as legs. So you need to understand the legs are the two sides that touch. How can I do this? Work. Yeah, there we go. That'll work. So the legs are the two sides that touch the right angle. So one side here touches that right angle. One side here touches that right angle. That other side, that doesn't touch the right angle. The right angle is across from it, which is actually the way I normally remember. So C is across from the right angle. What is C also called? The other two are A and B are legs. C is called what? What? Head, not the head. Oh, legs and head. Seriously, not the head. You can call it that. I don't care what. It's a weird, another Greek, weird Greek thing. It's not hippopotamus. Nobody remembers. Nobody knows after I said that. Hypotenuse. So C is called the hypotenuse. So you'll hear me use it. You'll see it in the book. C is the longest side. It's across from the right angle. It's called the hypotenuse. It's in your book. If you don't spell it correctly, you'll see it many times. So what we're saying is if we take one of the short sides and square it, plus the other short side and square it, doesn't matter which short side is which, and then we take the long side and square it, the sum of these two squared plus, equals the square of the longest side. Always, like that is a given for a right triangle. As soon as you see a right angle in there, 90 degrees or the right angle symbol, this needs to pop into your head. So every time you see that, make that note. For a right triangle, a squared plus b squared equals c squared. The more times you write it, or you'll start to remember it. There's something I was going to say. I forgot what it was. This is a mistake kids make a lot. I didn't talk about this last class, but I'm recording this one luckily. So do not add A and B together first and then square them. You will not get the same exact or answer. If my sides are 3 and 4, if A equals 3, B equals 4, I don't say 3 plus 4 is 7, and then 7 squared is 49. It doesn't work like that. I would square them first. So 3 squared is 9. 4 squared is 16. So as you can see, I'm way off, not even close. Do not add the A and the B together, then square that number. You have to square the A, square the B, and then the C is by itself. And again, that's just order of operations. Like exponents comes before addition. So the last thing on triangles, get your pages out. The last pages we tore out started at 273. I mean, actually, you don't even have to get them out if you don't want to get them out. You can just take notes on what you're taking notes on. I'm going to use them, but if you want to just write this down, that's fine. There's not a whole lot to write. All right, so we did proving triangles are congruent on your last quiz. Quiz grades are in. You can look it up after you leave. Grades were probably better than that. The first page is 273. You're on page 311. I was just telling you to pack it. Yeah, you're on page 311. That's what a page this is. Right? We learned there are 4 ways to prove, and there are only 4 ways to prove 2 triangles are congruent. There's no other way. Like some of you tried to say other things. If you're asked to prove that 2 triangles are congruent, your answer up until today was one of 4 things. What were the 4 ways to prove it? I'm waiting on you. What were the 4 ways to prove congruence? 4 and only 4. Say it again. So side angle side was 1. What else? Angle angle side was 1. Somebody said 1, but I couldn't hear it. What else? Angle angle side we have. Sit in. 3 angles doesn't prove it because we said we can shrink or enlarge a triangle and the angles stay the same, but they would clearly be different sizes. So angle 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 is one that doesn't. So side, that's the same thing as that. Reversing the orders doesn't make it. Say again. Side. Yeah, all the sides being the same proves it. And then there's one more. So angle side angle was the 4th one. So those up until today were the only 4 ways to prove any 2 triangles were congruent. They didn't have to be right triangles. If we could say that one of those 4 things was true based on marks or based on numbers, then we can say they are congruent triangles. You can't say, oh, well, if you line this up or if you do that, that doesn't prove it. That's the definition of congruence. It doesn't prove anything. You have to use one of those 4 things unless it's a right triangle. If it's a right triangle, then there are some other ways that we bring in. Although technically, we're not really bringing anything new in. So I'm not spending a bunch of this time. You could get some of these things on the midterms. They might specifically talk about a way to prove a right triangle is congruent. But the thing is you can use those 4 ways if you know it's a right triangle. As soon as you know it's a right triangle, you know one of the angles is congruent, like if you have 2 right triangles. So they say this brand new theorem, right? They're saying, oh, well, if it's a right triangle, then you can use leg. Leg proves congruence. Well, but what is that really the same thing as? Just if you didn't know anything about, yeah, side angle side, right? Like, we don't need leg for that. That's side angle side. If I know that it's a right angle, a right triangle, the legs will always surround the right angle. That's the definition of the legs, is they're the ones that surround the right angle. So that's really just side angle side. Again, why they have this whole different theorem for side angle side, I have no idea what they do. The next one, they say, oh, well, hey, here's a whole new one, right? Whole new theorem. We named a whole new theorem, hypotenuse angle. But if we know that we have a hypotenuse and one of the two angles, so not the right angle, but one of those two, what would we really just have? Doesn't matter which angle is congruent. It could have been this angle. Actually, this angle is congruent. I actually know this is congruent anyway, right? How do I know that angle is congruent? What tells me that that blue angle, the two, I should zoom in. I'll zoom in a minute. How do I know that that angle is congruent?
ABC is to DF.
Well, but we're trying to prove that. Let's say we don't know that yet. But if I know that these two angles are congruent in the two triangles, what allows me to say that that third angle has to be congruent? Well, those two, but let's just, even if it wasn't a right triangle, if you know two of the three angles are congruent, doesn't the third one have to be congruent? Because they have to add up to 180, right? So if I know in one triangle, I have 30 plus 70 plus a missing angle. That's one triangle, right? If I know in the other triangle, these two angles are congruent, again, I'm not even using a right triangle, but let's say one of them was 90. Well, if I know in the other triangle, I know two of the angles are congruent, well, that's got to be the same number, right? Because it's got to add up to 180. So whatever is missing in the two triangles has to be the same number to get to 180. If these two add up to the same thing, which they do, that's basically what this is telling us, they add up to the same thing, then the third one has to be the same also across both triangles. You don't understand that? Write this down. If you know that two of three angles in a triangle are congruent, so use whatever words you want. Two of the three angles are congruent across two triangles. So the two angles here are congruent to the two angles there. Or I could say it here if I knew this was congruent, and if I knew that was congruent, again, two of the angles are congruent across two actually, any two triangles. Two of the three angles are congruent across two different triangles. The third one has to be congruent because they always have to add up to 180. The only way to get to 180 is to add the same number here to whatever you have in the other angles. So the third angle has to be congruent if the first two angles. So again, they give you this big brand new theorem, but that's really just angle, side. Doesn't matter which way I go, angle, side. I'd have. Again, we don't need that. I don't know why they have all these theorems for right triangles. Just somebody trying to get their name on something, I'm guessing. Right? So, and again, the only time that will come into play, and it's possible it does, is if they try to make you do a proof and they try to use one of those theorems. Because any problems that you have to solve out, you'd be able to solve out by just understanding everything else we learned, four other ways we learned. Understanding a right angle means 90 degrees. So you'd be able to do any other ones. I want to go over though, just because they're in the book. Why it doesn't let me zoom in if I'm in full screen. All right, so here are the last two. They didn't give us pictures for these. So if we know one, I'm actually going to use that picture up there, even though it's not about this one. So if one leg and an acute angle of one right triangle are congruent to a corresponding leg, so it's the same thing as up here. Just imagine there's another triangle that looks like this. Instead of telling you that, because that's the hypotenuse, all they're saying is that one of the legs is congruent across both triangles. So they're telling you that. Well, what is that? ignore the fact that we have this whole new theorem for right triangle. What would that just be if we just used before we learned?
Side angle.
Yeah, it's just angle side angle, right? If we know there's a right angle, and then if we know, and it wouldn't have mattered which, because if I would have put it over here, it would have been angle side. So again, then we would have just used a different one, but you're going to be able to still prove they're congruent. You're going to understand that they're congruent and you're going to be able to solve. I'm hoping they don't give you these really weird one-off right triangle theorems. The only one I could see, so again, that would be angle, side angle. If you know one of the legs and one of the acute angles, that just means one of the other two angles that aren't the right angle. This is the only one that they could possibly give you. That is the most popular by far. It's called hypotenuse leg. EHL stands for. It says if you know that the hypotenuse and one of the legs are congruent, and again, you don't know anything about angles other than the fact that it's a right triangle. It does have to be a right triangle. If you know that's true, then they're saying that's enough to prove congruence, even though you don't know anything about any angles. Still, like, yeah, yeah. I didn't see anything other than your face, and it was just so awesome. Don't ever go to life with crime. Anyway, how do I know that that's congruent? What could I use? I do need to know that it's a right triangle, but once I know it's a right triangle, I don't need this hypotenuse leg theorem. There's actually another theorem I could have used. Not yet. I have to do one thing first, but you would have still been able to prove that they were congruent. I don't know anything about any angles, so I can't say angle side angle. I only know one angle, so I can't use anything. I can't do side angle side because the right angle is not. And we know that there's no profanity, so we can't use side angle. What am I missing, or what are we missing? What's the one thing I need to kind of fill in the gap and then say, okay, now I can say they're congruent triangle. What's true about all right triangles? What are we starting this lesson with? Right triangle. No, I'm just looking. Oh, what's true? What do we start out with? Right triangles. What's true? First thing I said you need to think about when you think about right triangles. I said the other two angles add up to 90, and then I said what? And I said it has nothing to do with the angles. Say it louder. Yeah, what was the theorem? You can just say the letters. Just say what the equation is. A squared plus B squared is C squared, right? So this is a right triangle, and then the other one would have to be a right triangle. I know that this has got to be true for both triangles. Well, if I know two of these three numbers are the same across both triangles, so it doesn't matter if I don't actually have the numbers, I know C is the same across both triangles. That's because we're working on hypotenuse leg. That's what they're telling us is congruent. So they're telling us one of the legs is congruent and the hypotenuse is, you say the plural of hypotenuse is so they're congruent. Well, if I know I got the same two numbers there, that has to be the same number. If I'm putting the same number here in an equation, like so in one triangle, we'll say it's a 3 and a 5, right? And then B squared. Well, if my other triangle has a hypotenuse and a leg that are the same, right? Well, then I'd have for the other triangle, I'd have the same equation. Right? Because these two pieces are congruent. It tells us that in the markings. Well, if those two numbers are the same across triangles, then when we solve, we're going to do the same exact equation twice. Like we're not going to do anything different. It's the same equation. So we're going to get the end result is going to be that this side is also congruent. That side has to be congruent if the other two sides are congruent. So we can prove that the third side is also congruent, meaning what do we really have? We're going back to our old reasons why triangle is congruent. Not so, well, we could now say side angle side, but what would we also? Yeah, we have side 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 too. So you could now say side angle side, you could say side side side. The key is though, if it's a right triangle, so again, here's your note to write if you're not getting this. If you know two of the three sides of two different right triangles are congruent, again, that would look like, I'll zoom back in now. That would look like this. I give you two right triangles. You know they're both right triangles. You know that that is true. All I give you. You know that third side has to be congruent. So if you know two of the three sides are congruent across two different right triangles. So again, I know two of the three sides are congruent across those two triangles. That side's congruent, that side's congruent. Then I know the third side has to be congruent. If you don't understand why, because of the whole a squared b squared c squared thing, you need to write that down and memorize it. Can't imagine that's not going to come into play somehow on. I don't know what's on your next quiz. It's made up. I haven't looked at it yet. And sometimes I'll adjust it a little bit, but definitely on the midterm, I'm sure there's going to be something to come into play with right triangles and something like that. All right, we got to go through this last part. I'm going to do them both together really fast. Any questions on that? All right, so the last piece we're doing today is I'm not even using book pages. It's the next lesson in your book, so we'll have to tear them out. So if I have, so this is on equilateral and isosceles triangles. And I'm just gonna kind of give you the information today. We'll do something more interactive with it on Tuesday. That didn't work good. Son of a gun. All right, here, I'm not gonna do that then. Do this. So there are two types of triangles that you need to understand and the properties of them, and then I'll briefly show you what kind of equations you could get or what kind of problems you'll probably see. If I know that the two sides or two of these sides of a triangle are congruent, so they're the same length. Talking about sides, that means the length. That means these angles are the same measure. Automatically, no exception. When you hear me say no exceptions, it's something that you better like ingrain in your memory. Two of the sides are congruent. The two, but they call them the base angles. They're like the angles that are at the bottom of both of the sides. So those two angles are congruent. It goes the other way as well. If I know that, I don't know if I'll be able to erase this or not. If I know, I'll just redraw a triangle. If I know that the two angles are congruent at the base, and again, the base could be anywhere. Like I could have drawn these two are congruent. Well, then that means the two sides are congruent. So it goes both ways. It's an automatic thing. You just need to understand that's the way, that's the relationship. They're not going to always tell you all four. Actually, they'll almost never tell you all four of those things. They'll just tell you two things. Either the sides are congruent or the angles are congruent. You then have to make the connection that, oh, okay, that means that either the two angles are congruent or the sides are congruent, depending on what they give you initially. That's called an isosceles triangle. And an equilateral triangle, and I cannot tell you anything about that triangle. Can't tell you how long a side is, can't tell you how big an angle is. I know all three angles still add up to 180, which you'll definitely use in isosceles triangles, but I can't tell you any numbers unless they give me numbers. For an equilateral triangle, I know all three sides are the same length. If I know all three sides are the same length, then I know all three angles are also the same measure as each other. Like they have nothing to do with the sides. So the three angles are the same measure if the three sides are the same length. Or it goes the other way. If I know that the three angles are the same measure, then I know that the three sides are the same length. Again, depending on what they give you, you have to make the other connection. Now, I can tell you something about a number in that. Anybody have any idea what number you can give me? Even though I've given you 0 numbers, you can solve for something in that triangle. What do we know about triangles? Not a right triangle, so we can't use anything, and even if we could, we don't. Oh boy, we know in every triangle, the three interior angles add up to 180. But what's true about that triangle? What else is true? The markings. What are the markings saying about the angles? They're so congruent means they're the same, right? So if I know that those three angles have to add up to 180, I also know they have to be the same number, right? That's what congruent means. They're the same number. I can solve that equation. I only have one variable. So even though I don't know any of them, I know they have to be the same number. That allows me to solve. So if you do the math on that, 3x equals 180, divide by 3. So again, dividing by 3 here gets rid of the 3, dividing that by 3. So again, if you don't know how to do that, for now, just write it down. For an equilateral triangle. Actually, the word equilateral, it's not up there. Actually, I'll write both of them. Equilateral. And then isosceles was the other one. Isosceles is the one where two sides and two angles are congruent. Equilateral, should be able to remember that. Equal means they're all equal angles and sides. So for an equilateral triangle, all three sides are 60 degrees. I'm sorry, all three angles. Each individual angle is 60 because they all three have to be the same. And they all three have to add up to 180. So that's another shortcut that will save you some time if they give you something like this, like they might say solve for x. That's all they give you. Nothing about sides, which you wouldn't need anyway, it's not about sides. The reason they give you the sides, though, is so you know, well, wait a minute, if all the sides are congruent, all the angles are congruent, so I could say they're all 3x, and I could say 3x plus 3x plus 3x equals 180. Or if I understand this, if I understand that each angle is just 60 degrees, I could have just immediately said, okay, well, I know if that's an equilateral triangle, 3x has to equal 60. So I'd solve that out. X has to equal 20. 3x divided by 3, 60 divided by 3. The problems over here are going to be kind of similar. They might give you that the two sides are the same, and then all they give you is 2x. That's it. And then they say, well, actually, they wouldn't be able to give you just that. They have to give you one more piece. So there. But they don't give us the third one. But what do we know is true? It's isosceles, and we know those two sides are the same length. So what else do we know is true? So this is the concept you need to immediately see. When you see those two sides are the same, you should immediately say, okay, well, if those two sides are the same, the two angles are the same, the base angles. So that is also 2x. Now, what's true of all triangles? So that is your equation. Somehow you're going to have a piece of information you have to fill in based on what type of triangle it is, based on the congruence marks that they give you. And then from there, another kind of problem I'll show you. I don't remember what it was. So again, you're going to use 2 or 3 concepts in all of these problems when you're doing equilateral and isosceles. The first concept will be about equilateral or isosceles, like you'll have to fill some missing piece in based on the congruence marks that they give you. Could be about sides also, like they might tell you something like this. Well, this is, they might not tell you the sides are equal. They might tell you the angles are equal. Well, then you would have to say, okay, well, if my angles are equal, I know the sides are equal. And then there'd be some kind of an equation you'd have to use to fill in, to solve. All right, so really quickly. Set up and solve the equation. Go. For x, solve for x. Pretty much just what I showed you. And we will be practicing this a lot more on Tuesday for you guys. So what's the first? Oh, shoot. I didn't tell you the information. I didn't give you that. Hopefully you kind of figured out. It was up there, I think, before the race. So what does that tell me? I know that's true. What else is true? This is 2x. That's the first concept you have to be able to recall. Now, again, all 3 angles add up to 180 would be your equation. And then you solve, and I think it's 39.5.
Yeah.
Solve it out. So that's the algebra gets a little more complex, but that concept is the same for every isosceles triangle problem. You need to make the connection that the 2 sides are congruent or the 2 base angles are congruent based on whatever they give you initially. I'll assign problems next class and we'll do some review on that. So